So far we've discussed limits where we get an answer of infinity and vertical asymptotes. Now it's time to find limits at infinity and horizontal asymptotes. At the end of this lesson, you'll be able to discuss the end behavior of a function and find the horizontal asymptotes. All right, what exactly is end behavior? It's basically what happens to the function f of x as x increases without bound or as x decreases without bound. What I'm talking about that when x increases without bound, it's basically as you're headed towards the right, as the x values are headed towards the right side of your paper. And then when x decreases without bound, it's basically just looking as you're heading to the left of the graph, what's happening. When I'm discussing end behavior, my answer to my end behavior problem will be a y value. So just same thing as a limit is a y value, end behavior is also a y value. So let's look at some examples. In the first example, you'll notice I have a nice picture. It first of all asks me to find the limit as x approaches infinity. So as I'm headed towards the right side of my paper, what y value is my function headed towards? And it looks like I'm headed towards a y value of 0. So my limit will be 0. And now as x approaches infinity, negative infinity, I'm going to be heading towards the left side of my paper. And again, I notice I'm reaching towards a y value of 0. So the limit for both of those is equal to 0. All right, the next one, the limit as x approaches infinity. As I head towards the right side of my paper, I'm looking at what y value am I headed towards, and it looks like I'm heading towards infinity. And then as x approaches negative infinity, as I'm heading towards the left side of my graph, my y value again is approaching infinity. Okay, we'll notice in this case both of them turned out to be the same thing. They don't necessarily have to, as you can see in this next example. Okay, first again, limit as x approaches infinity, we're going to go as I head towards the right side of the paper. You'll notice I'm heading towards a y value of 0, so that limit will be 0. And then this one, you'll notice as I'm heading towards infinity, it doesn't really look like I'm ever going to get to 0. It looks like I'm getting closer to a y value of 1, so that the limit on that part will be 1. So notice I got two different answers, and that's totally okay for these problems. Right, example 4. Find the limit as x approaches infinity again. So as I'm heading towards the right, notice I really would just keep this pattern on going, and there really is no y value that I'm approaching because I keep toggling back and forth between 1 and negative 1. So in this one, I would have to write the limit does not exist. And then same thing as I'm approaching negative infinity, as I head towards the left, once again, I'm just going to keep toggling back and forth between 1 and negative 1, so there's no specific 1 value that I'm heading towards. So again, that limit will not exist. All right, now if we can take a look at the definition of horizontal asymptote, it's basically the line y equals L is a horizontal asymptote of the graph of f if the limit as I approach negative infinity or the limit as I approach infinity is equal to some L. And remember, L is an actual number. It's not infinity. It's like 5 or 2 or whatever. So basically, once you find the limit, you have also found the horizontal asymptote. And please keep in mind that the horizontal asymptote, it is a line. So we always want to write it as y equals something because that would represent the equation of a line. So I'm going to go back to the previous examples, and now let's go ahead and label horizontal asymptotes. So in this first example, if I would like to record my horizontal asymptotes, okay, I'm basically just going to look at my limits. My limits were both equal to 0, so my horizontal asymptote will be the line y equals 0. And if you'll notice, if I drew it, it's very obvious that that function is actually approaching that line. Okay, if you look at example 2, the limits are both infinity. There's no specific value, finite value that the function approaches. And notice there's really no line that the function is headed towards. So in this problem, there is no horizontal asymptote. Okay, you will be asked on these one to justify your answers. On this one, I would say there is a horizontal asymptote at y equals 0 because the limit as x approaches infinity is equal to 0. On this one, I would say there's no horizontal asymptote because the limit as x approaches infinity or negative infinity is infinity. All right, let's take a look at example 3. Notice on this one, excuse me, I have actually two different limits, so I actually will have two horizontal asymptotes. And my horizontal asymptotes will be y equals 0 and y equals 1. It's just whatever the limit turns out to be, that's the horizontal asymptote. So you'll notice I actually would have a horizontal asymptote here, and I'd have another asymptote at 1. Now you'll notice one kind of interesting thing that you can see. Vertical asymptotes can never be crossed. If you'll notice on this one, horizontal asymptotes can be crossed, because you'll notice this one right here, both of those asymptotes were crossed, and that's totally okay. They just represent something a little bit different. So I'm just going to write down here that horizontal asymptotes, because of the nature of what they are, thought I'd get better at writing on this thing, and that just has not happened yet. Okay, or horizontal asymptotes can be crossed. Okay, and then the next one, since my limit does not exist, obviously there can be no horizontal asymptotes. Okay, and just one other point that I'm going to bring up. You'll notice on those last examples I had one horizontal asymptote and some I didn't have any, and in my last example I have 2. Kind of point out, can you ever have more than 2? Since they just rely on your limit as x approaches infinity or negative infinity, no, but we can have up to 2 horizontal asymptotes. And now hopefully you can find a horizontal asymptote and discuss end behavior.